In this very short video segment, we are looking at contact switches and impact collisions. In order to analyze the contact dynamics, what we have to do is we have to look at the impulse transfer at contact over a single point of time. In order to do that, what we do is we integrate the dynamics equations of motion over one instant, so this t0. So what we do is we write this mu dot plus b plus g plus contact forces. We put the right hand side of the dynamics equations of motion here with a minus sign. We integrate over the dt. So everything which is a force that is non-infinite has to drop out. So b has to drop out, g has to drop out, and the torque has to drop out. So what remains is we have m times the velocity after the impact minus the velocity before the impact plus j transpose times, now we write an fc with this calligraphic f, which stands for an impulse. So fc calligraphic is essentially force times dt, so an impulsive force. We know that the post-impact velocity condition is that this contact is not allowed to move. So jc times u plus must be 0. And that means I can insert this in here. And I can now, what I can do is I solve this for u dot. I insert in here and I calculate then my impulsive force. My list jcq dot minus, this is u minus. So I solve for my contact force, and what I see here is again this same jcm minus 1 jc transposed, which is this end effector inertia, this lambda c. So the impulsive force is nothing else than the end effector inertia times the pre-impact velocity at the contact point. That makes a lot of sense. In other words, what we have here is mass times velocity before the impact, and that gives me the impulsive force. But just all of that for a much more complex system where this lambda c is highly configuration dependent. We can then also analyze what is the change in generalized velocity. So this delta u, and this delta u is nothing else than I insert, essentially I calculate this delta u from here. So I do m minus 1 jc transpose times fc, and I take this fc from up here. So I see how the pre-impact velocity is mapped to the delta u. I can then also calculate the post-impact velocity, which is the pre-impact velocity plus the delta u. And if I do that, I get this element in here, which we have seen in the last video segment, which corresponds to this NC. So in other words, this same null space projection matrix that gives me this support consistent dynamic equation of motion is the one which maps the pre-impact joint space velocity into the post-impact joint velocity. And I can also look at the energy loss that is happening in here, which is essentially only a kinetic loss. I don't have potential losses because I'm looking at one instant in time. The only thing that changes is the velocity. So I have the velocity coming from the delta in u, and if I calculate this in here, I again just have this lambda that I'm seeing there. So it's the inertia times the pre-impact velocity squared at the point of contact.